Experiment 10 deals with the enthalpy of hydration. And enthalpy is just a way of measuring the amount of heat a reaction gives off or absorbs without worrying about the amount of work that is done by the chemical reaction. This week's requirements are that you complete the Experiment 10 PreLab quiz, watch the procedure videos, including this PreLab talk, complete the Excel file, which contains data for you to do your calculations, and then upload your lab notebook as a PDF to the required assignment. We are going to be dealing with hydrates and anhydrous compounds in this lab. So hydrates are where water gets incorporated into the chemical structure to form a new compound with different properties. And an anhydrous salt can be turned into a hydrate by adding a very specific amount of water and incorporating that into the structure. Now, this is a reversible process. We can form anhydrous salts if we take a hydrate and heat it up, driving that water off of the chemical, evaporating the water out of the structure. When we name hydrates, we name them just like the ionic compound, but we add a prefix telling us the number of water molecules that are present. And to say that it's water, we use the word hydrate. So here is an example where we have copper 2 sulfate, and if we add 5 water molecules into that structure, it becomes copper 2 sulfate. The 5 is pentahydrate. Hydrate meaning that there's water. We write the structure by drawing a dot between the ionic compound and the water molecules. If we want to calculate the molar mass, we calculate the molar mass of the ionic compound, and then we have to add in the number of water molecules. So if there's 2 water molecules, it's 2 times the mass of water. If there's 6 water molecules, it is 6 times the mass of water. And that gets added to the original anhydrous or salt compound. So it's just added together to get our molar mass. You will have to calculate the molar mass of magnesium sulfate and also magnesium sulfate heptahydrate for this lab. We are going to be looking at the surroundings. So we are going to measure the solution because the solution is going to absorb all of the heat that the reaction gives off, or it's going to provide the heat that the reaction needs. And it's much easier to measure the water molecules and the excess water molecules surrounding the reaction than it is the individual molecules that are participating in the reaction. So we measure the surroundings, and from that we can calculate the reaction just by putting a negative sign in front of it, because whatever heat the solution absorbs, the reaction is giving off. So they're exactly equal in value but opposite in sign. To calculate the heat of our solution, we're going to be looking at the mass of our solution times the specific heat of the solution, which is 3.84 joules per gram degree Celsius. It's provided for you in your manual as well. And that is multiplied by the change in temperature, or the final temperature minus the initial temperature of the final temperature after we add our compound minus the initial temperature before we add the compound. If the reaction is exothermic, it's going to give off heat and the temperature of the water is going to increase. If the reaction is endothermic, it's going to absorb heat and the temperature of the water is going to decrease. And there is one of each of these in the reactions that we're looking at today. In this experiment, our goal is to figure out the amount of heat that the reaction gives off or absorbs for an anhydrous salt adding just the right amount of water in order to form the hydrated complex. So we're taking magnesium sulfate and adding 7 water molecules to form magnesium sulfate heptahydrate. That is delta H1. This is a very difficult reaction to do experimentally because adding just the right amount of water is very difficult. But what we can do is we can measure 2 other reactions that are very easy to do, and from those calculate the difficult reaction. That is why Hess's law is so helpful and important in chemistry. So the reactions that we're going to be measuring are taking a hydrated compound, adding lots of excess water, dissolving that hydrated compound. That allows us to calculate the delta H2. We can also take an anhydrous salt, in this case magnesium sulfate, add lots of excess water, and dissolve that anhydrous salt. That would help us calculate delta H3, and that's also a very easy reaction to do. Using those 2 delta H's, it allows us to calculate the enthalpy of hydration. So for Hess's law, we would take delta H1 plus delta H2 equals delta H3. But because we're trying to solve for delta H1, we need to rearrange that chemical or that equation. And so we can solve for delta H1. It's going to be equal to delta H3 minus delta H2. So our overall enthalpy of dissolving the anhydrous salt minus the enthalpy of dissolving the hydrated compound. It is very important that you keep track of the signs on your chemical reactions, because that does change the overall enthalpy of hydration if you're not careful with those signs. So remember, a negative means that it's an exothermic reaction, it's giving off heat. A positive sign means it's endothermic, it means it's gaining heat from the surroundings. The calculations for this lab are available for you, and they're outlined on pages 75 and 76 of your lab manual. Some helpful reminders for doing the calculations is that if we want to find the enthalpy of the reaction, that's equal to the opposite or the negative value of the heat of solution. So remember, mass of solution times specific heat of solution times the change in temperature of the solution. If you put a negative sign in front of that, it's the enthalpy of your reaction. If you want to find the enthalpy per mole, which is helpful because it helps to standardize the measurements that you're making, all you have to do is take the enthalpy that you calculated and divide by the number of moles of the compound. So either the magnesium sulfate or the magnesium sulfate heptahydrate. That makes the numbers easier to compare to each other. And if we want to find the enthalpy of hydration, which is delta H1, we take delta H3 minus delta H2 in order to find the enthalpy of hydration. Be careful of your signs. Make sure that you're using the proper positive or negative signs in your calculations. Thank you, and good luck on your lab.